Welcome to my first video on binary numbers. I will first be going over decimal numbers to strengthen your understanding of this before moving on to binary numbers. They have a lot of similarities, so this is why it's important to understand decimal or base 10. So we know that for decimal, we have 10 symbols we can use, 0 through 9, and we know that each digit corresponds to a different place. So the first digit corresponds to the ones place, second digit is the tens place, third digit is the hundreds place, and so on and so forth. So this corresponds to 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, so on and so forth. So we notice that this base is 10. Right? So as soon as we get to a new exponent of 10, we need to add another digit to the left of our current digit. What I mean by this is, say we have 99 and we add 1 to that, we know that 100 is the next exponent of 10, so we need to account for a new digit. So I hope that makes intuitive sense to you, and we will be applying the same idea over into binary numbers. So instead of having 10 symbols to choose from, we now will only have 2 symbols to choose from, 0 and 1. And instead of having an exponent of 10, now our exponent will be 2, right? So the symbols that we use are 0 and 1, and as soon as we get to an exponent of 2 now, we need to add another digit to the left of our current digit. So as we can see in this table, we have the ones place, and now instead of the tens place, it's the twos place, and the fourths place, and the eighths place, and so on and so forth. And this corresponds to 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on and so forth for each next digit. And we see that the only thing that has changed is that we now only have 2 symbols, 0 and 1, and our base is now 2. So everything works the same, but now when we reach a new exponent of 2, we need to add another digit to the left of our current digit. So say we have 0, 1, oh no, 2 is the next power of 2. So we need to shift over 1. We need to add another digit to the left of our current digit, right? So that's what we did right here. We added the next, right? When we reached 4, we added another digit, right? So feel free to pause the video and look over this table a little more if it helps you understand binary numbers, but I will be moving on to 2 quick examples of binary numbers and conversion from binary to decimal and decimal to binary. So we'll start binary to decimal. So what we do for this is, say we have, for example, our binary number 101010. All we do is take the value in each digit, right, in each column, and multiply it by the value of that column. So it would be like, for example, 1 times the value of the column is 2, plus 0 times the value of 1. So let's look at this example. We see 0 times 2 to the power of 0 is 0, plus 1 times 2 to the power of 1 is 2, plus 0 times 2 to the power of 2 is 0, plus 1 times 2 to the power of 3 is 8, plus 0 times 2 to the power of 4 is 0, plus 1 times 2 to the power of 5 is 32. Add that all together and we get our decimal number of 42. I have color coded this so it's easier for you to understand, but I will move on to our next question of converting decimal to binary. So how do we do this? How do we change this decimal number to a binary number? Well, it's very simple. All we need to remember is that we need to find the greatest power of 2 that can be taken away from our decimal number. So in this example, our decimal number is 17, and the greatest power of 2 that we can take away from this is 16, corresponding to the digit at 2 to the power of 4, which will be the 5th digit. So now we have found the largest power of 2 we can take away from this number, so this will be our max bit for our binary. So we set this max bit to 1, so as you can see here, 16 corresponds to 2 to the power of 4, which is the 5th digit. We mark that as 1, and all the preceding digits as 0. So 2 to the power of 3 as 0, 2 to the power of 2 as 0, 2 to the power of 1 as 0, 2 to the power of 0 as 0. Now we take our original 17 decimal number and subtract this 16 from it, and we are left with 1. So now this is what we have left to do, left to convert to binary. So now we continue finding the next greatest power of 2 until we have reached this value number to 0. So in this example, the next greatest power of 2 is going to be 2 to the power of 0, which is 1. So we mark this 2 to the power of 0 bit as 1, and now we subtract 1 from 1 and see that we have achieved 0 as in our decimal number, and we know our answer is finished. Our answer is 10001, is the binary 17 for decimal 17. If you like this video, please give me a thumbs up and subscribe. If you have any comments, concerns, or would like me to do any other types of videos, please leave those in the comments. Thank you.